Radians. You've heard it. Some of you have probably used it. But what is a radian? A radian has to do with the idea of taking a circle's radius and wrapping it around the perimeter of the circle. Okay, so there's a million different definitions. There's some that talk about measuring angles, the radians based on the pure idea of the radius being laid along the circumference of the circle, talking about pi and all of that. What I want you guys to understand is that a radian, okay, is another way to measure if we're thinking about a circle. Okay, a radian is another way to talk about measurement of a rotation around the center of the circle. Okay, it's a measurement of, and we saw this back at the beginning of this unit, it's a measurement of the central angle in relation to its intercepted arc. Okay, sorry, I have this horrific tickle in my throat. It's really annoying. So 1 radian, you guys don't have to know this, it's just more interesting. 1 radian is approximately 57.3 degrees. Okay, so obviously that's not going to work for us. Let's go back real quick to the unit circle, and I want to think about labeling a few angles in radians based on the distance around the circle, okay, and the patterns that we find. So I believe it's page 4. Nope. 5. Nope. 3. Nope. I don't have any idea what's going on with my unit circle. Okay, so there's that extra line that we have, yeah, and that's for the radian measure. Okay, so if we are at 0, well, obviously that's 0 pi radians. Remember, a radian is talking about putting the radius of a circle, or let's rewind, it's talking about the central angle and its intercepted arc in a circle, right? Circles, the whole circumference of a circle is 2 pi r, right? So we're dealing with pi with our radians. Degrees have the degree symbol. Radians have pi because that's how you measure the circumference in the area of a circle. You use pi, this 3.1415926, yada, yada, yada. Okay, so if we go all the way around the circle to 180 degrees, this is pi radians. Now, 90 degrees is half of that, right? So it only makes sense that 90 degrees is pi over 2. If I'm at 180 and I continue to go another 180 degrees to 360, that makes sense that I'm adding another pi, so that's 2 pi radians. Okay, 360 degrees is 2 pi radians. Well, shoot, cut that in half, right? Where am I at? Okay, so if I'm at 0, I go pi over 2 up to 90, then 2 pi over 2, because I'm adding in 90 degrees. So then 270 is 3 pi over 2. If I continue, I would be at 4 pi over 2 or 2 pi. Yep, good. Okay, before we add the rest of it, let's go back and let's look at the conversions. There is a way to convert. Okay, we can use a conversion to change from degrees to radians. So if I am going from degrees to radians, they're radical. Never gets old. Okay, so we take the degree measurement and we are going to multiply that by pi over 180 degrees. Your units of measure will cancel out. It doesn't say dog, it looks like dog. And then you'll be left with the radian measure. If you're going from radians to degrees, you'll have some radian measure in pi, and you're going to multiply that by 180 degrees over, oh, for the love, there we go, over pi. Okay, so let's say we have 45 degrees, right? We're going into radian measure, so I'm going to multiply this by pi over 180 degrees. The degrees will cancel because we're going into radian measure anyway, so that's logical. And we get 45 pi over 180. Well, let's reduce by 5, okay? So, because remember, simplest form. So we get 9 pi over, what is that? 5 goes into 3 times, ha, very good, 36. And then we reduce, so sweet. So that's pi over 4. Well, come back up here with me. Okay, so we know that 45 degrees then is going to be, oh God bless it. It's going to be equivalent to pi over 4. Let's take a look at 30. Okay, so we multiply that by pi over 180. We get 30 pi over 180 reduced by 10, 3 and 18, so pi over 6. Okay, so 30 degrees is equivalent to pi over 6. Well, the other special angle we have is 60, so let's use our conversion table. Okay, our degrees are going to cancel. We get 60 pi over 180. The zeros cancel, and we can reduce by 6, so we get pi over 3. Excellent. Okay, go back to our unit circle. Nice thing is you guys can pause if I'm going too fast for you. The 45s. Okay, if I'm traveling around my unit circle, well, now we just found that 45 is equivalent to pi over 4 radians. Well, when we first created this unit circle, we added, right? 45, another 45, 90, another 45, 135, another 45, 180, and so forth. The same thing is going to happen with our radian measure. If we can do it with degrees, we can do it with radians. So pi over 4, which means this is 2 pi over 4, which we can absolutely reduce to pi over 2. But for the purpose of right now, stick with me, okay? Pi over 4, 2 pi over 4. This is 3 pi over 4. Keep adding. This becomes 4 pi over 4. Keep going. This is 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. I'm just adding like fractions, okay? And this becomes 8 pi over 4, which reduces to 2 pi. Nice. Yes. Okay, patterns. If you are a 45-degree reference angle, regardless of what quadrant you're in, your denominator will always be 4. Very good. It will always be 4. Okay, let's look at some other patterns because you're going to have to memorize this with the degree measures, yeah? Every quadrant has an odd numerator. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now, if you need to, you can absolutely create it just like we did, okay? And then reduce from there. So I would have kept my 2 pi over 4 and reduced and so forth. Okay, let's do the 60. 60 we converted to find that this was pi over 3. Okay, so when we went around and created the unit circle, we did 60. 60 plus 60 is 120, and then 180, and then 240, 300, 360. We're going to do the same thing with pi over 3. Okay, so pi over 3, 2 pi over 3, 3 pi over 3, which reduces, but for the purpose of right now, keep it, okay? This is 4 pi over 3, 5 pi over 3, 6 pi over 3, which absolutely reduces to 2 pi. Good. Sorry, my 3 looked icky. Okay, so patterns. If you are a 60-degree reference angle, your denominator is always 3. Good. Other patterns, this one's a little bit trickier, but in the first quadrant, it's pi over 3, then 2 pi over 3, and then 3 at 180. And then you just go 2, 4, 5, and then 6. So 1, 2, 4, 5. Okay, however best you can remember that. I just go around in my head and write down the ones that I need as I'm counting. Okay, 30 we found to be pi over 6. So it has a denominator of 6. 30 is the one that we added a heck of a lot of times. Okay, so as you're creating your unit circle, you might want to do 30 instead of adding the 60s because it goes 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360 as we were adding. So you can do that with your radians also and then just reduce if that's easier. Let's do it. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, there we go, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Some people prefer this method and then just to go back and reduce. Some people don't like it because they don't want to reduce. But if you're somebody that doesn't mind taking the time to do that, 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2, and so forth. Okay, so if you want to create your unit circle radian measures that way, you can. I just want to show you guys the options, okay? Your unit circle's complete. It's so beautiful. So awesome. Okay, let's go back to our notes for this and do some more math. Okay, so negative 225, we're converting to radian measure. Why? Because the direction said so. Okay, so that means that we are going to take negative. Do not lose the negative. So often students do, okay? And then you get it wrong because it's not a positive measurement. Okay, we're going to multiply it by 180. So the degrees cancel. Go ahead and immediately put that negative. So negative 225 pi over 180. Excellent. And let's reduce. Its GCF is definitely going to be 5. So that numerator reduces to 45. The denominator reduces to 36 like we saw in example A. So then we get negative 45 pi over 36, but we can keep reducing. So that means we get negative 5 pi over 4. Having seen our unit circle, if the denominator is 4, that means that it's a reference angle of 45 degrees. Well done. Okay, go ahead and try 90. I know that you guys know. Okay, so pause my video and then hit play. Did you pause? I hope so. Okay, so I'm going to multiply by pi over 180. Hopefully you did that as well. It gives us 90 pi over 180, reduced by 10, reduced by 9. So we get pi over 2 radians, which we know is what 90 degrees is. Rad, nice job, guys. Okay, so pi over 3 into degrees. We know it should be denominator of 3. What is it? What is it? What is it? Yes, it should be a 60-degree reference angle. But let's use the conversion so we can practice with that. We're going from radians to degrees. So I'm going to multiply by 180 degrees over pi. The pi's will cancel. I get 180 over 3 degrees, which we know is 60 degrees. Excellent. Okay, for these two, again, pause my video. Pause it, and try yourself. Welcome back. I hope you paused. Okay, so for A, we see right away that it's got that denominator of 4, so we know it's going to be a 45-degree reference angle. And when we work it out, we get negative 135 degrees. Did you get the negative? I sure hope so. Okay, 3 radians, that's a little bit tricky. Might have thrown you off because they didn't have a pi. It's still radian measure. So when you multiply, you get this guy. Okay, don't leave the pi in the denominator. I would hope you would use a calculator because realistically it's degrees and we would need to round. Tenths is fine. Okay, excellent. I hope you guys did well on those. As far as, I know I'm a stickler on the degree bubble. You don't have to write radians. Okay, so in example number 1, we didn't put pi over 2 rad. Okay, or radians. You can, but since there's a pi in it, I'm going to assume that you understand it's in radian measure. I will be a stickler on the degree bubble for degrees, but not for radians. Okay, last but not least, coterminal. Coterminal means that we are separated by what? Yes, very good. We're separated by multiples of 360 degrees, which is what in radian measure? You can look at your unit circle. Some of you might have said it. It is 2 pi. Okay. So 1 positive and 1 negative coterminal angle. These answers will vary, okay? As long as it's separated by some multiple of 2 pi, I'm good. Okay, so 11 pi over 4. I'm going to subtract first and see where that takes me, okay? But we need common denominators. So it's 11 pi over 4 minus 8 pi over 4, and that gives me 3 pi over 4. Now I see that that's positive, and I'm asked for 1 positive and 1 negative, so I'm going to use that as my answer. And then I'm going to continue off of 3 pi over 4 and subtract 8 pi over 4, because I know that that's going to give me a negative measurement, in this case, negative 5 pi over 4. There's my 1 positive and 1 negative coterminal angle. you're more than welcome to keep going. Let's say you added the 2 pi, so you got 19 pi over 4, totally fine. You would just have to keep subtracting to get that negative, okay? For here, I know, cheater, pumpkin eater, 3 pi over 4 is in that first example. Okay, we'll keep going. So just to 3 pi over 4, let's subtract 2 pi, see where it takes us. Shh, stop looking at the previous example. So we get 3 pi over 4 minus 8 pi over 4 because we need common denominators. If you need to write that on your notes, you guys, you have to get common denominators. Yes, 2 pi is 360 degrees. Coterminal angles are separated by multiples of 360 degrees. However, we're in radian measure and we have denominators, so those rules still apply. Okay, so I'm going to take negative 5 pi over 4 as my positive, and then I'm going to go ahead and add, which we know what's going to happen, but shush, just keep going. So we get 11 pi over 4, and there's the positive, there's the negative coterminal angles. Rad! Welcome to Radians.